There we go. Got that going. Good morning, good afternoon, good evening to people around the world. This is the host of the Db2 Night Show, Martin Hubel, and we are at show number 242. And I think we're in our 13th year, so we've been doing this a good long time. And this show is as special as many others, if not more so. We've got Piotr Mierzejewski of the IBM Toronto lab, IBM Canada lab. I'm not sure what if it's in Toronto, it's IBM Canada. We know that, right? Because we're really important here in Toronto. How are you doing today, Piotr?
I'm very well. Excited to share some exciting news.
Yes,
a little bit of a vision where Db2 is evolving.
We always love to have you on the show, and it's great. We've had great lab directors in the past who never really wanted to present, so we're always excited when you want to get on and share knowledge straight from the top. We enjoy that a lot. Let me get through the housekeeping here. As always, our social media page, hashtag Db2Night on Twitter, is probably the most important thing you can do. The second most important thing these days is to look for the replays on YouTube. I've been noticing that numbers of people using YouTube rather than having to go through a download are going up, and that's great to see. It's nice that we moved into the 21st century when we started doing that, or the second decade of the 21st century. Nudge, nudge, wink, wink. Here's our disclaimer. I remember the days when I used to read this all the way through, and I should do that for practice, but maybe I'll do that on my own just to not make you suffer through it. We're recording it. We respect trademarks, and we're interested in providing good content, and we will have the replay. Other quick announcements. New shows. We've got Jim Bean of Cigna coming back next month on Db2 LUW to talk about the second half of his presentation. When he informed me he had 90 slides, I said, well, there's a number of things we could do. Pick a topic, or we could give you 2 slots. And we opted for the 2 slots. And it's always great to have users tell you what they're doing as opposed to people telling you what you should do based on how it looks. And Jim Bean has a great deal of experience at Cigna. Good stuff. On the Z side, we've got things a little more fleshed out. We've got Hawk and Roberts next week speaking on utilities, and there's vNext coming this year for Db2 on Z, but this is an update of things that are new before vNext, and that's next week. Then we have Michael Cotignola coming on March 18th, and things about Db2 I wish I'd remember one. It's not really the same as Bonnie Baker, but it's sort of along the same theme as you go through. There's important things we need to remember. And Cheryl Larson will be joining us in April to talk about how to slow Db2 down in one summer. That's one of those negative type titles that I've come through myself over the years. And Cheryl always does a great job of presenting things, and we love to have Cheryl on the show. As always, DBI Software is the founding sponsor of the Db2 Night Show, the founder. And as such, we always like to make sure we put a plug in for their products. And their demo is available off their website. If you watch it, you get a gift card, and that's available to you. Congratulations, Melissa Case of CSGI. It's interesting when I saw her name pop up. I worked with Missy, I guess, back in the late 90s, back in the days when PeopleSoft was a thing. She was supporting that as an outsourcer. And it was good to see she's still working at it, like we all are. That's good. So congratulations to Melissa. And as I mentioned, DBI is our founding sponsor, and yours truly, Martin Hubel Consulting, is the other sponsor, as we donate our time to the Db2 user community to make this happen. And this is an old cartoon, but it still strikes me as a good one based on the tremendous amount of snow. We had record-breaking snow last month in Toronto, and we're still digging out. I still got a pile 4 feet high on my front lawn. And so when you're up in these colder climes, you got to be careful to make sure you check other hiding places for animals around your car. So this is one you do. This one might be a little more obvious than others, but there you go. Another Meanwhile in Canada cartoon. And now we're into our polls before we turn it over to Piotr. And we'll launch the first one, which is our typical question of what versions of Db2 are you currently running? And that should be open, and we are seeing things come in. It's nice to see people are getting onto the new function service packs for function level. 11.5.3, 11.5.7 is our current one, or the current one available to us. And we have a couple of people running old stuff. That's not necessarily because they're old. It's probably because it's really important. It's sometimes a little harder, or you're waiting for vendor support before you can move on. So let's close that off. A lot of people voted today. Share the result on that. And people are getting more current. That's great to see. Let's move along and do the next question. What other commercial DBMSs? This is the age-old question. The world we live in today, what other DBMSs do you have? GoToWebinar only gives me 5 choices. So when I say other mainframe DBMSs, that's often IMS, but there are some people out there running some other older funky things. That's how things go. And we got a lot of people are voting quickly today, so let's move this along quickly. As always, the majority of our audience has Db2 on Z, and then there are other flavors of non-mainframe DBMSs, and always some other stuff lying around on the mainframe. We've asked this question off and on over the last while. It's still an important one. IBM spent a lot of time.
And perhaps let me put a little spin over here.
Yes.
I know in the past we kept talking about OpenShift only.
Mm-hmm.
I should have reserved these questions to any Kubernetes distribution. So it could be AKS, EKS, Google Cloud, Kubernetes, Rancher, for example, for on-prem. So not only OpenShift.
Yeah. Some people, the majority of my customers still, Piotr, are running on their own iron. And
also this is a big switch in our strategy. So
yes.
In the past, we've been always OpenShift only. And yes, OpenShift is recommended. However, we will be announcing Q1, Q2.
Yeah.
We will be announcing our support for other Kubernetes distributions.
Great.
Fully certified. I believe the order will be Amazon Kubernetes Service, Azure Kubernetes Service, Google Kubernetes Service, and then Rancher and a Minikube for developers.
Great. Good news.
Well, that the user group, Amber and others, they helped a lot. They helped a lot with our higher executives to realize that perhaps OpenShift alone mandate is not ideal for some of our customers.
Yes, very true. We've got some big customers out there who also have important relationships with IBM, but they're also using other technologies. And, so we got Db2 graph, the Db2 graph question up, and having a look at this. And interesting. Let's close that off and share the results. Db2 graph has not gotten the traction expected.
Okay. Have we had a Db2 graph session on the show?
I believe so.
Okay, maybe we need a repeat.
Yeah, do we need we need a big stick. And I remember going to do an IBM internal gold consultant briefing, and one of the speakers got up one time and said, sometimes you need a carrot on a stick to lead people the right direction, and sometimes you need an orange stick. All right, I'll launch this question here. Are you interested in virtualization technology?
And perhaps federation would also be in the same umbrella.
Yes, yeah.
Because some people are actually, traditionally, we always spoke about federation. Db2 Federation has been there for a decade or so, right? So virtualization is evolution of federation technology. So perhaps both.
Yeah.
If we get on, yeah.
Okay, we've got enough people voted on this. We'll share this. People are looking at the poll results there.
Okay. All right.
Good. Okay. And I think
so. I'm glad there is the general interest in the virtualization / federation, because there will be lots of that and some more during this session today.
Perfect. And that's great. Okay, now I've closed the polls. We should be back to looking at move your mouse. I've got a commercial break, but we won't do that now. We'll do that when you have a chance. But of course, over the years, we've done so many commercials. We'll see what the timing's like. If you feel you need a brief break, we'll show a little video that the DBI has given me. But from there, we'll move on and turn things over to you. And I'll make you the presenter.
Thank you.
And you can take it away. Click. Yes. There you go.
Yep. Show my main screen. Wonderful. I can see it already. It's showing.
Yep.
Good afternoon. Good morning, everybody. I'm so happy to be here again. So today's topic might be a little bit different. We're not going to talk about core Db2 capability, but rather we're going to take a look how the landscape of relational databases and big data is evolving. And in context of that, we're going to talk about Watson query / data virtualization, which is, I hope it's going to become evident through all this thing, it's a Db2 technology. And the highest level, it's basically evolution of our Db2 federation that's expanding its use cases, and it's providing new capabilities that are actually trying to keep up with how landscape and market is changing. Okay, we're going to go through an overview of what some query is, our IBM's vision. We'll then look at technical details, what's underpinning it, and then we're going to go through actual typical use case, how would this actually look like. At any point in time, if you have a question, just put them in the question tab. I will occasionally pause here, and if there are some questions, then I will try to answer.
Yes, I'm also monitoring the queue as well, and I'll remind you. So.
All right. So the goal, what is behind it? Well, the landscape has changed. Now, organizations over decades, and I really like this response that while we had people using Db2, but then also the ZOS, ISO SQL Server at 80%, it's Oracle, Teradata, you name it. In reality, it means that within your shop, you have not one, not two, but often 3 or 4 various relational databases. We could have added over there, for example, Hadoop. I wouldn't be surprised if many of our customers actually have a data lakes or are process to moving data lake, or in the case of a hybrid cloud, the evolution of hybrid cloud, as we move away from just on-prem to actually hybrid cloud paradigms, object store is often used, for example, for the cold data storage to lower your costs, right? So what we're trying to do here with Watson Query is being able to expose all the organizations to critical data assets that you have invested in over decades and create a single pane of glass and abstract the complexities come with the location, platform, technologies, and schemas. An ability to query anywhere from 2 to 2,000 data systems with one single query syntax. And yes, it is Db2 query syntax SQL that you normally work with Db2. Use that SQL to create a single view, single basically query interface across all your investments that you have made in your enterprise. That's a goal, and it's a far-fetching goal, okay? Obviously, that's not something that's done easily because we're looking at so many varying SQL dialects. Things like, for example, MongoDB, which is document store, it's not even relational. We're gonna talk in the context of Excel spreadsheets and how they can play a role when, for example, business analysts in your enterprise would like to join it with the Db2 data or data that your enterprise has an object store already for archiving perspective or investments in Hadoop. So when we look right now at the classic big data architecture, you have your data lakes or object stores, and then you actually have your ETL processes for your BI reporting, usually moving the data into the business warehouses. So complex, difficult to scale, difficult to maintain, duplication of data, right? So those are challenges. What we try in the modern big data architecture, when it actually to satisfy, to provide the data for BI reporting, data science, is creating a single query engine that can span across all your data lakes, cloud object storage, and relational databases, and non-relational as well. In essence, we want to create a vision when there's a single query interface on top of object store, HDFS, relational databases, document stores like Mongo, or even to the extreme of a querying Excel spreadsheet. That's the vision, how this would look like, and what the experience would be. So as I keep saying, one query experience of virtualizing multiple warehouses, OLTP databases, data lakes, so on and so forth, all running on a hybrid cloud. So Watson Query, while available as a SaaS offering in IBM Cloud and soon to be available on AWS, is also available on-prem in a hybrid cloud. And a vehicle of choice is containers, so Kubernetes, OpenShift. Now, what are the principles? Open data formats. Okay, we're supposed to work with all the data formats, open data formats that are there, any cloud on-prem. Scalability, we're not longer talking about gigabytes, terabytes. We're talking about the petabyte scale. We see our customers, there is essentially explosion of data, and the data is increasing not only by percentage right now, but often multiplying. It's a multiplying in volume year-by-year basis. Now, obviously, cloud native, instant deployments, full elasticity with separation of storage and compute, so scalable services that I can actually scale in and scale out depending on my peak workloads and data volumes. And as I mentioned, hybrid cloud, so on-prem, private cloud, and the public clouds. Obviously, within that ecosystem, there is additional integration points, which I want to cover further, because this goes beyond just regular data virtualization, federation data virtualization technology. Watson Query actually provides you more than that. Now, within this, when we're talking about now, we're actually starting to talk about large distributed systems, right? Large distributed systems that deal with, again, relational data, Hadoop data, object store data. That's why direct access and caching without data movement, and here's the key, without data movement and caching the results and making recommendations is the key principle of this. So I guess that graphic, perhaps a little bit busy, but it's self-explanatory. External repositories like Snowflake or Teradata or Oracle, external data lake storage like S3, GCP, blob storage, cloud object store in IBM Cloud, and everything from warehousing, data lake, Spark, and Netezza, all integrated into single SQL distributed query engine. Now, it is a vision that is perhaps hard to conceive, but it's something that we at IBM have been working for some time. And the key differentiation architecture we would like to talk about is the move away from a traditional hub and spoke model. Okay, and if you look at the top picture, this is precisely how Db2 federation technology has been architected over a decade ago and how it's working. So we have a coordinator node, we have a query results processing going to individual data sources, right? And then coordinating back at the coordinator. So as you can see, from that architecture point of view, coordinating becomes the bottleneck. So if you're working with 1, 2, 3, maybe 5 data sources, and they are kind of geographically in the same region, that model still can work. However, when you move towards distributed, geographic dispersed distributed systems, that architecture fails. Instead, what we've introduced with Watson Query / data virtualization, and the reason I keep saying data virtualization / Watson Query, data virtualization has been available for about 2 years. We are rebranding it to the Watson Query as we've integrated additional capabilities I'm going to talk about. So when you think about Watson Query, you can think of evolution of federation and Db2 warehouse and inclusion of data virtualization capabilities with computational mesh, as well as our Db2 Big SQL technology. For some of you, that name might be familiar. Db2 Big SQL is our Hadoop optimized offering. This was something that was evolving through our partnership with Hortonworks and current with Cloudera. That's been focused on processing of HDFS, as well as optimized query access for data inside the object store. All of those offerings are coming together in what we're calling Watson Query. Now, The computational mesh is unique because it does not rely on a coordinated node to conduct all the query processing and communication with all the remote data sources. We have introduced the concept of a computational mesh. Computational mesh is something, as described, it's essentially a constellation of many agents. Those are binaries, those are installable binaries. They're installed near the data source we want to push, we want to query, and allow for communication between the agents themselves. As you can imagine, just from some high-level overview, when we start filtering the data and basically filtering the data between the agents themselves, the computational mesh is offloading tons of processing that would be happening in a coordinator node in our previous generation technology. So what is really coming back, the Watson query does the query by pushing the data, breaking down the queries into individual dialects, and we're going to get into that in a more technical overview for other slides, but it actually breaks down, does the translation from a normal SQL that you use with Db2 to a syntax of, let's say, Z, to the syntax of Oracle or SQL Server or MongoDB, or actually object store or Hadoop, does this breakdown, does the translation, and executes the data at the source, executes the query at the source, and only the results are being filtered down between the agents and returned back to the coordinated Watson query service. Additionally, we introduce additional capabilities to help with distributed query processing. Like, first of all, caching and policies. We're going to go through them. The scalability of the service, ability to scale independently the remote agents without affecting the processing, the current processing, and just increasing the throughput. So it provides the resiliency between a connection data sources. It has a seamless addition of the new the data sources and agents to the network. Richness is automatic, basically recognition of the query patterns and recommendation engines. Yes, based on MQTs, and many of you probably are aware. So material as query tables, we've had it for quite some time. This technology has been now introduced into the Watson query to provide recommendation for the caching policies. So highly distributed parallel processing. So essentially a query engine of the future that is capable of working with, oh, sorry, not there yet. Sorry, I'm gonna actually come back to this slide. So essentially, as it stands right now, this is the list of Watson query supported data sources. As you can see, obviously the whole Db2 family from HDM, Db2Z, Big SQL, IDA, so IBM stock that you've been working with and familiar with, Amazon RDS, Oracle, SQL Server, Derby, you name it, PostgreSQL, Hive, Teradata, MongoDB, Excel spreadsheet, text files. So this goes beyond the actual engine, but with our agents, this computational mesh, we can actually consume flat files and look at them as if they were part of a column or a schema definition of regular virtual table. So Snowflake, the list keeps growing. In essence, what we're trying to highlight is that every quarter you can expect addition of another data source, and our complete list. I'm not going to say we're going to complete every single data source there is out there, database, relational, but as you can see, we are at about 24 data sources currently being supported, with another 10 to 15 coming between 2022, second half of 22, and early 2023. So how does this really work? Okay, so yes, we do have a primary head node. That's that's where the coordination to the remote worker is happening. However, the unique part is that each of the remote agents can then be installed, as is actually described over here. So the part that is above the network, okay, this is actually internally within the Watson query engine. So we have remote agents over there that handle all the communications, data flow, disaggregated I/O, and those workers can be actually scaled. So you can start with as little as one worker. If your workloads increase, you can keep adding the workers without disruption to the service itself. So this is what we talked about: distributing computing, scalable computing that allows you to scale with your query needs. Now, additionally, when you look below the network part, you see the remote agents. And those agents are installed as close to the distributed, basically the system, It could be an IBM cloud, could be an AWS, could be on-prem, and then to improve basically the network latency, to alleviate the need to ship the data and results and even the aggregates between where the Watson query resides and your remote data stores. We'll do this aggregations, filtering, everything by the source itself. And another very important point, yes, the data can be filtered out. The remote agents, they have a self-discovery mechanism. As a remote agent is added to this constellation, it is being discovered, added to the service, the type of data source is being registered, and then the agent is capable of doing translation from a Db2 SQL syntax to native syntax of the data source you're actually interacting with. All right. Now, from Db2 Optimizer, so again, multi-worker support, so it can scale horizontally and vertically. Their DB removed agents support high number of connected data sources and multi-source queries. And finally, Db2 Optimizer dynamically selects the best path, the best query access path for the specific data source. All right, we already went through this list. Now, so this is on a high level. So I hope become evident that Db2 is evolving to be a data platform of the future. It's no longer focusing only on OLTP or traditional warehousing processing. It now spans and creates the single query interface across heterogeneous data stores and the data assets, regardless if they're on-prem, in the private or public clouds. Let's talk about what's under the hood. Okay, so it sounds very good from on a very high level. I would hope so. But what is really happening under the hood? Okay, so first of all, data and result caching. So cache, well, we've approached cache in twofold. We have actually recommendation cache engine that is based on MQTs, materials query tables. And our MQT, this is traditional, Db2 technology has been evolving for a decade right now, are based on the two types. It could be a table-based MQT, where we look at the table access that is being frequently accessed by the queries, and we actually cache the most popular, the hot data that's being constantly accessed. Additional one is based on actual queries that are being executed. So we have pre-trained, within Watson query, you have a pre-trained machine learning model that has been trained on TPCDS 99 queries workload. That machine learning model looks at the patterns of the queries that are coming into the Watson query and recommends the query patterns to be persisted as a cache. Now, how this actually works out, so we collect the query workload characteristics, we extract internally query cache candidates, we translate them into cache definitions, which is either the table or a query itself. We evaluate our metrics, scan them, basically sort them up, and we provide the best recommendation that matches your current workload. At this point, we're going to be enhancing these capabilities. Right now, it's a pre-canned machine learning model. We will be adding in a 1H and a 2H of 2022 capabilities for you to retrain this model on the fly to adopt to your varying workloads of actual workload that you're running. So at this point, is a static ML cache that it represents quite a broad range from a TPCDS 99 of the query patterns that we can expect to see in the enterprise. However, our evolution of the technology will allow you to actually dynamically retrain the model to represent the workload that you currently work on. And of course, as with previous MQTs, we still, even though there's a recommendation engine for those, you can still define them yourself, being a query-based MQT or a table-based MQT. So as you can imagine, when it comes to large distributed systems, for the data, and let's talk about use cases for caching, right? So if your data is changing constantly, at by second, by minute, you name it, well, perhaps such query MQT or a table MQT might not be sufficient. However, for warehousing applications, when data doesn't change every hour, every minute, but can change on a daily basis or nightly or weekly basis, this setting up such cache MQTs are an excellent way to speeding up your query processing, lowering the cost of data movement and access to actual each of the data sources. So that data and result caching. Another enhancement we have created is that it's a new problem essentially. Well, it's not a new problem. So data duplication across database systems that you have it's often a large problem for our enterprises. You have systems where in two databases, let's say two databases, for example, you have your customer tables and you have your, say, transaction tables, right? So common elements with a similar schema elements that then in a Watson query, we essentially fold in those schemas and represent such similar data structures as the one virtualized object. So from management perspective, when you're interacting with them, when you're querying them, that basically simplifies your query access because this is becoming abstracted. And you have the one virtualized data point that now describes the changes from both of your data sources. Service compute scalability. Okay, so this is actually interesting because, it's one thing to say, all right, so I'm going to get predictable performance. Now, can I scale up as my workload fluctuates? Obviously, the workloads in the peak hours are totally different than something you see on a day-to-day basis. We see daily peaks. We see perhaps monthly or weekly, monthly or seasonal peaks where you don't want to have, basically, you need to have a capacity for your peaks, or whether it be day, month, year. However, you don't want to keep paying for infrastructure and resources to actually run these services. So with Watson Query Data Virtualization Service, you can scale your worker nodes, and it's a matter of minutes before your new computational node is actually deployed. And as per data above, I'm not going to say it's a linear scaling. However, you do get with each worker that you deploy, your performance and ability to execute is actually improving. So with each scale out, you can handle much more larger workload, and it's very easy to scale down the service itself. And we are working for automated scaling in and out that is based on the volumes of data that the Watson query is to process. Now, language translation. So obviously, you've seen the list of 25 various data stores. Each of them have their own unique dialects. Yes, there's a SQL, there's common SQL element, but as we know, Oracle has a slightly different SQL, Z has a slightly different SQL than LUW, so does SQL Server, so on and so forth. So within Watson Query Service, we handle the translation. So supported versions of SQL, Oracle, Netezza, etc. We do internal translation inside the remote connectors. So when the data is being accessed in the original data source, let's say a SQL Server, that dialect has already been translated for you. Now, what does this do? Well, obviously, you work with one single SQL syntax. The differences between are abstracted. You don't have to worry about your applications being rewritten to write properly querying as Oracle, SQL Server, and Db2. Now you can have an application talking the same dialect, and Watson Query handles that translation. Security. Obviously paramount, especially when we're talking about distributed systems. So overall, Watson Query, and I would like to take the security in a couple different segments. So obviously, the data lives in the original source, and only results are being transmitted. So right away, if you're using Db2 native encryption, we're not shifting the data like in the federation technology and moving it back to the coordinator node in a Watson Query. This is all being pushed down to the engine, and only results are being transmitted backwards. Obviously, the encryption, TLS 1.2, I believe, it's a full encryption communication between all the components of the solution, meaning internal communication between the agents is encrypted, as well as communication from Watson Query Engine to this distributed constellation. We have a strong authentication and permission management. There's policy enforcement and masking. User group supports when it comes to AD and LDAP integration. Obviously, as part of enterprise readiness, this is a must. And here is where we're going to get into slightly different angle of what Watson Query actually brings to the table. And what I want to talk about is actually governance. Okay. Now, to have a data virtualization technology and federation technology is one aspect. Yes, there's a huge value in it, right? Your data is dispersed, is across various silos. You have now created essentially, and what we see over here is a screen caps for the, for example, constellation when running in a Watson Query, right? But there's so much more. As you might be aware, IBM has a very strong governance portfolio, okay? And when we're talking about governance, it's business rules, policy enforcements, let's say masking, reduction rules. And one of the value propositions of Watson Query is that we've created a tight integration between Watson Knowledge Catalog, which is IBM's governance, the next generation governance portfolio, and our distributed query engine. What this means is that we are uniquely positioned to provide geographically dispersed, governed data virtualization. And that's what ultimately the Watson query is. So you have 5 data stores, okay? Yeah, excellent. You have your governance team that says specific business rules and policies, let's say reductions of the social insurance numbers or credit card numbers, right? And yet your data is dispersed in 5 different locations. Normally, traditionally, your governance policies would have to be applied at each individual data source. With Watson query and integration with Watson Knowledge Catalog, we are able to define those policies once. Those policies are actually applied onto remote agents in data virtualization and executed in real time. So every time you execute the query, if the policy applied has changed, this actually will change as well. In turn, what you get is a masked, redacted, governed data that in turn you can push out to basically business applications or data scientists or application developers. And here I believe it's a very unique value proposition of what IBM portfolio brings together. Because one of the hardest things in enterprise software is integration of the various silos of organization. And we already know of challenges of integrating data between the heterogeneous data stores. Here, we're talking about the full end-to-end flow integration of governance policies, business catalogs, applied in real time on distributed system virtualization technology that then is governed and fed into your machine learning, applications, and business analysts. Now, from a flow perspective, how does integration look like? And by the way, this is fully abstracted. This is fully abstracted for actual users. This, what the flows that you actually see over here, is actual internal underpinning and how we call on each other's APIs. And the flow would be very simple. So when we virtualize data source, and let's say for simplicity's sake, I'm going to have Oracle and Db2. So I've created my virtual view. Now I have my perhaps schema folded. I have my remote connectors deployed. Okay, and then I'm just going to publish it to catalog. Once this is published, this asset is published to catalog, data steward can define classification, scoring, and a term association. Now, the beauty about it is this is done in an automated fashion. DBA or data steward doesn't need to go automatically and start mapping, this is customer entity, this is this kind of entity, this is a product, so on and so forth. This is done automatically. It's automated discovery of the virtualized data asset that has been presented to our catalog. Once discovery is completed, we're retrieving the business terms that has been discovered on this data asset, and they're being published to the catalog. Now, at the same time, we're picking up any business enforcement rules, and I'm going to keep going to the reduction, for example, or masking. Those are the 2 most popular that we see right now. Actually, data replacement, data reduction, or data masking, depending on the business rule, right? And that information, those are actually applied, and we are using CUDFs, so user-defined functions, Db2, they're unfenced, to actually apply this on a cell-by-cell basis. Now, what you get in return, you get governed, distributed data asset that has a business terms and policies applied and enforced. I don't believe there is an offering out there that actually provides this level of integration of sophistication. Now, what problem are we really trying to solve? So yeah, on the surface, this is all great. I mean, it looks like exciting stuff. I can do all those various things. There's some sleek UIs over there. But what is the real problem that we're trying to solve? And what are the opportunities here? What is the key value of the data fabric with Watson query integrated together? Well, using data without knowing format, location, moving on, copying it. That's huge. Because if I have to copy the data across the network, and we know that when we go to the public clouds, there's ingress charges. Moving data over the network costs money, right? So the more data we can keep locality, it's not only cost saving, not only performance and time saving, but also implications to security. Ease of query access. I mean, that seems like a table stakes. No, I don't need to write 4 different applications in 4 different SQL dialects. I can just use the one and let the Watson query engine handle the translation for me. Obviously, hybrid, this is a key, which means Watson query can give you access, single this point of access to your on-prem, cloud, and private data. Scalable from 1 to 1,000 data sources. We've actually created a demo one time that had We did use Raspberry Pis for it, but we've created a network of 1,000 agents constellation, and that thing hold it up. So it's definitely scalable, distributed between regional and governed, which is very important. We have quite a few of our clients that are saying, due to GDPR and various rules, there's data locality rules, meaning the data cannot leave specific geography or jurisdiction, right? Watson query allows you to do that. Watson query will not move, let's say, data from an India data center in Db2 over there and shift it to the United States, which will not be allowed. Watson query will process this data, edit where it lives, and will only return aggregated result. Last but not least, another unique proposition, governed, which means policies that have been defined during search, they are applied during runtime and usage of the query. Now, the benefits, well, those should be kind of known. So definitely time and effort to access. Once you define your virtual objects, you can publish them across organization, and your other developers, application engineers, whatnot, they can just request data access. They make request data access. Means, can I use this data access? And if it's approved, then they don't have to recreate it. It's all available. Use of data effectively, meaning no data replication, no data movement throughout the network. Time to value, well, you know what, you spend your time, the discovery of the creation of the catalog is automated. Yes, it takes some time depending on the volumes of the data, but then you know your data quality, which was done for you. You have your business terms extracted, where your business analyst can just confirm or deny, and then you just keep running. And then obviously modernization of your technology stack. With Watson Query, you are not forced to decommission or migrate the data from your older offerings. And if you're something on mainframe, what do I do with it? I want to use this data. Do I have to migrate it off? No, you don't. No, you don't. So it allows you to modernize your stack, allows you to embrace the journey to hybrid cloud, and still investing in the new repositories while having access and a single access to your repositories of the past. Right, so steps to increment time to resolute and with the reduced effort. So I'm gonna go through the, I'm sorry, I don't have it here in the live demo, but I do have a screen caps to walk you through scenarios, how something what I just described verbally would look like inside a Watson query. So we'll start, let's say, searching existing assets. Why would I start creating something if a catalog already contains set of catalog tables, catalog data assets, DBs, you name it? And with ease of fingertips, by using common language or tags or labels, you can actually search through available data sources, which you see on the left side. So here we have a mostly, well, Derby and ZOS Hive. So as you can see, you already have a visual view what data stores already participate in my basically catalog. You can then, when accessing such catalog, you can look for terms, and they're right there. And then you can just assign, you can join with them, you can use them, automate, and publish to the user group, so on and so forth. This will be your first step. Now, if you didn't find the asset, you can virtualize asset, and you can do the quick scan. Sorry, that's internal term we're using. You can perform the business term discovery and data quality analysis of each asset. At the end, when the analysis is complete, you will have the suggested business terms, unassigned, assigned business terms. You also get quality of the data that is available in that data source. All in comprehensive dashboards full of statistics, easy to consume, and give you the view of the data that you're actually interacting with. Now, if indeed you need to discover, design the, sorry, this chart should have been done a little bit better. However, with this visual exploration, you can also discover relationships between the different data stores and the data that's been put into your constellation. So those relationships, they're following primary and foreign keys constraints that have been created in this virtualized view. You can actually create this virtual topology of the constellation and data stores that you've actually connected together. Also, what you can actually do is actually use a basis of one virtualized object to create the other. Now, this can be done in a multitude of ways. It can be done via visual interface when you're allowed to just drag and drop and create these relationships, or you can do it traditionally via SQL editor. And the outcome is essentially constellation that you see on the left-hand side, which in this case combines MongoDB, Informix, Db2, flat file, and a SQL Server edition. Last but not least, you are able to basically create those connectors and share those with participants in the platform. So Watson Query is part of Cloud Pak for Data platform, and which point once those virtualized assets are created, you can actually publish them. You can publish them to the catalog to be used by different parts of your organization. So this helps with an organization. You have your data engineers, you have your data stewards, you have your application developers, data scientists, and with this way, we can just publish once this asset has been generated. Once the governance rules have been applied and the business term assigned, we then publishing this to the machine learning project or development project, and right away they have access, governed data access to distributed data systems. All right, so that was a lot. That was a lot. Maybe, you know what, I don't know, did I fast track to this or not? Well, we have 13 minutes left. I hope all this has generated at least a few questions. So perhaps we could open it up, Martin. I don't know if people can ask questions verbally or do we go through the chat part, but I hope this has basically highlighted, at least on a high level, how we are evolving Db2 engine to provide essentially distributed data platform, governed data platform across heterogeneous data stores, across multiple clouds, in an easy, consumable fashion.
Great. Now, what I've done is I've got the attendees open in front of me, and if you can raise your hand as an attendee, I'll open your mic and you can ask a question, or you can type it in the traditional Db2 Night Show fashion. I think there's an awful lot to absorb there. And a question from Titia in the Netherlands. For what kind of business would this be useful?
We have customers anywhere from healthcare. So whenever you have a very sensitive data that has been persisted as the business was evolving in a heterogeneous data stores, so investments, hence one of the questions earlier is, does your company invest something beyond Db2? And the answer became obvious, right? We have an Oracle shop, we have within one shop we can see Oracle, SQL Server, maybe Teradata, Db2, and maybe some pieces of Hadoop Lake and stuff like this. So for any of those situations, and we see this pattern in financial services, healthcare services, government, so on and so forth, if your shop has more than one database and your applications that you have would benefit from accessing the data, single point of access, Watson Query plays a role here. Now, if the information is sensitive and there is geographical considerations, meaning the data we would like to use the results of this data in some different application residing in a different geo, but we cannot move the data, the Watson Query would help. If you want to create governed virtualized assets consumed for your data scientists, for your application developers, Watson Query plays over here. So anytime you have and if you invest in a hybrid cloud, yet you want to write applications that accessing data between on-prem and your new cloud infrastructure, Watson Query can help you. All of those use cases.
Great. And I think most of the people are saying thanks, and there's a lot of information to digest. I think it seems to be the most common comments I'm seeing back on the presentation. So with that, I think we will assume that people have asked their questions, and I think what we'll do is ask our audience one more polling question, so I'll take back control and do that.
Thank you, Martin.
Thank you. That's great. Now, let me just make myself the presenter here, show my screen. There we go. And the last question, as always on the Db2 Night Show, is, did you learn anything? Surprise, surprise. Our audience is just finishing voting here, and some people said no. It's just a surprise to me, but 88% of our audience said yes, which is always good news. And as always, Piotr, we're always happy to have you on the Db2 Night Show because hearing it from planning and all the things that go into making the IBM lab work, you're the man, and we're always happy to have you here. And with that, we'll give people back just about 5 minutes of their day before lunch here on the East Coast. One thing I've learned as I go through life is I generally like to eat lunch. So some days, you just look forward to that sandwich. So with that, let me cue the music. Thank you once again. We'll be making the replay available shortly for those people that want to share it with other people in their organization. And with that, thanks to all. Thanks again, Piotr, and we'll call it a wrap. And we'll see you next time on the Db2 Night Show.
Wonderful. Thank you very much.
Thank you. Bye-bye.